Hey YouTube, welcome back. Today we will talk about how Lambda handles asynchronous invocations. So AWS Lambda handles asynchronous invocation differently compared to synchronous one. When Lambda function is invoked asynchronously, AWS Lambda queues the event for processing and returns the response immediately. And the function execution then happens independently and in the background. So you can look at this one. So when we invoke the functions, we have the event, we go to the event queue, we get a response immediately to say that we and the Lambda runtime process acknowledge that we have a function that we are running, and after that we run the function in the background. So we the there are some key aspects when it comes to the asynchronous invocation in AWS. And the things that I would like to talk about first is the invocation process by itself. So in asynchronous invocation, when you invoke a function, Lambda sends the event to an internal queue. It's a separate process, reads events from the queue and runs your functions, which is this one we call the event queue. And after that, we have an immediate response. And the response to asynchronous invocation is not the results of the function's code execution. Instead, it's acknowledgement that Lambda has received the event and queued it for processing. And after that, we have error handling. So if your function returns an error or times out, Lambda retries the invocation twice with delays between retries after 3 attempts. If the function still doesn't succeed, the event is discarded or sent to dead letter Q, which is the Q if configured. Number 4, we want to talk about the dead letter Q. So you can configure a Lambda function with a dead letter Q as an SNS or SCQS queue or SNS topic to capture event that failed processing. This is useful for debugging and ensuring that ensuring that no event data is lost. After that, we have the event source mapping. It's So for AWS services that integrate with Lambda, such as S3 and SNS, the event source service is responsible for retrying the invocation when your function returns an error. And number 6, we have the use case that I want to talk about. Asynchronous invocation are suitable for scenarios where the immediate response of the function is not critical. Examples including processing log files, triggering workflows, or handling events where the order of processing is not important. Number 7, we want to talk about the logging and monitoring. So you can monitor asynchronous invocation using AWS CloudWatch. Logs generated by your function's execution are sent to the CloudWatch, and you can set up alarms for monitor and failure. I want to talk about some best practices, but it's just some like overview of them. And I would say one is in terms of the error handling. Like implement a robust error handling in your Lambda function to manage the the retries effectively, using a try catch block to handle known errors conditions, for example. Number 2, we have the DLQ configuration. So set up a dead letter queue for capturing failed invocations, which allows you to analyze and respond to them. Number 3, we have monitoring. So regularly monitor CloudWatch metrics and logs to keep track of your function's performance and error rates. Number 4, I will say it will be the idempotency. So ensure your Lambda function is idempotent, meaning it can handle duplicate invocation safely, as the trier can cause the same event to the delivered more than once. So asynchronous invocations in AWS Lambda provide a powerful way to handle event-driven background processing, allowing applications to be more responsive and efficient by offering longer tasks. So that's it for this video, and I hope you like my content. If you like my content, subscribe and hit the notification bell so you'll never miss a video, and see you in future problem.